Hi friends, I'm Amayangdi and today I'm going to introduce to you my project Desk32. Let us understand the problem statement. The problem is very clear. In the modern age, smart devices like smartphones, laptops, desktops, etc. were introduced initially to improve productivity. They came with useful softwares and apps that allowed users to do their work and be productive. In this current world, with the development of internet, these devices have deviated from the main purpose of productivity. These devices are now bombarding notifications, have distraction-based apps like Instagram, YouTube, Facebook, Netflix, and within a few touches, you could just go from doing something productive to doing something that is a waste of time. You go on scrolling reels, you watch web series, or just get lost in the internet. So I wanted to develop a device which was capable of removing all these distractions and ensuring that a focus space is created. So to solve this problem, I have come up with a unique solution called as Desk32. Desk32 is a unique solution which allows the user to be productive by using a device which allows the user to use a Pomodoro timer, a task list, and also it has health reminders like drinking water, meditating, calming down, taking a stretch, taking a walk, etc. All of these features are some crucial features that makes the person's day very productive. It ensures that a calm and peaceful workplace is created that remains distraction free. Now let us have a look at the project. As soon as you turn on the switch, a wonderful animation of the Desk32 appears on the display, showing that the display is loading. As soon as you load, a main screen appears with the following details. So now let me explain the different features that are available in the product. As you can see, there is a digital clock on the main interface. It includes main information like the time in 12-hour format, followed by the day, date, temperature, and humidity. All the basic details that would just help you understand your environment better and keeps a sense of time. The next screen is the essential screen called as the Pomodoro timer. The Pomodoro timer is a technique where users take 25 minutes of time for working, followed by a quick 5-minute break. So in this interface, there is a timer. Once you start the button, the timer starts running. As soon as the timer ends, you get a break time of 5 minutes. In this, the device suggests that you drink water, take a walk, or go have a stretch, etc. Further, there is also an option to cancel the focus timer. The next feature that is included in this device is called as the Task Manager. The Task Manager has a text box at the top. As soon as you click on the text box, a keyboard appears. The keyboard allows the user to enter tasks into the text box. For example, I am adding some task on the device. Once you click on the tick button, the task is added to the list. Now, the user has the following options. The user can mark a task complete by clicking on the checkbox. As a result, the task will be striked and it will indicate that the task is completed. Also, if the user is making a mistake in entering the task, he can delete it by using the cross button. By using a task list, this device allows the users to keep a track of the things that they have to do, allowing them to ensure that they remain productive throughout the day and are able to clearly understand the number of things that they have to do and are able to accordingly manage and schedule their day. So the next interface that is used is a simple calendar interface. Like any productive environment would have, a simple calendar interface allows the user to plan their next week, see a date in a glance. So it was an essential feature that surely had to be there. The next interface is the device settings interface. The device settings interface is a useful interface as it allows the user to know important information about the device and control certain settings about the device. For example, the first part is the SSID name. The SSID name tells which Wi-Fi network the device is connected to. The next thing is status. It tells whether the device is connected to the Wi-Fi network or not. After this, you have two buttons, refresh temperature and sync time. Refresh temperature and sync time allow the user to refresh the temperature and sync the time by using the Wi-Fi connection. The next is a toggle switch which allows the user to enable the water reminder. The water reminder is a health feature which is integrated in this device. This feature allows the user to get frequent reminders at an interval of half an hour, which reminds the user to drink water and hydrate themselves. The next part of this interface is a brightness control menu. The brightness control scroll bar allows the user to adjust the brightness of the device. After this, there is a simple About Me page which tells the details of the device like the version, the name of the creator, that is me, and the last part is a QR code. The QR code links the device to the GitHub page. You can scan the QR code to know more about the device and how it has been made using the GitHub QR code. That's all about the number of features that are included in this device. So now let us understand how the UI was designed. The UI was designed using an app called as SquareLine Studios. It integrates LVGL library along with this app to create user interfaces that look professional and very pleasing to the eye. This is the SquareLine Studio interface. In this interface, you have a loading screen, a home screen, the Pomodoro screen, the task list screen, the calendar screen, settings screen, about screen, and the hydrate screen. All of these user interfaces have been designed over here with the required functions, buttons, labels, and a variety of other elements. All of these files are available for download on the GitHub page. In the below section, you can see all the different fonts and icons that have been used, which are attached as assets. Now let us understand the code. The whole device has been coded using Arduino IDE, which mainly uses C and C++ languages. So this is the code. In this code, as you can see, there are certain basic libraries like Arduino.h, Wi-Fi.h, HTTP client, and others. These libraries allow the board to connect to the Wi-Fi network, to access data from the internet by using NTP servers and OpenWeather's API key. Further, there are some libraries which manage the graphics like LVGL, which also control the display. The next part includes some user-defined variables where users are allowed to change the Wi-Fi name, the Wi-Fi credentials, add their own API key, a city, the country in which they live, etc. Further, the code is used to define a number of functions which perform the tasks on the board. These tasks include a wide range of functions like the Pomodoro timer, the water reminder controls, a function to update time, function to update weather, etc. Further, after defining these functions, we go to the main void setup part. In the void setup part, the basic UI is introduced. The UI is loaded into the board. Further, basic details like the brightness of the display is set to the predefined value, that is 100. The water reminder is set on by default, and other such default configurations are set up in the void setup function. Then the next part is the void loop function. The void loop function is a function which is going to run continuously and ensure that the time is updated at every second and the weather is updated at an interval of 15 minutes. And further, it also ensures that if the Pomodoro timer is running, then the timer continues to run even in the background. All these functions ensure that the device works smoothly without any bugs, and also even if the screen loses focus, it should be able to run the timer, to update the time, to update the weather and other functions in the background without performing any type of delays. So that is about the code. While uploading the code to the device, ensure that you select the ESP32-S3 box in the list of available devices. For this, you might be needed to install the ESP32 library from GitHub, which could be installed by following other tutorials. The current Arduino IDE does not support ESP32-S3-BOX-3, and hence we are going with ESP32-S3-BOX. But as of all, everything works normally and the code is able to run properly. For the very first time when you're uploading the code to the board, it might take a long time for the code to upload. This is because the compilation of UI files and loading of all the assets takes some amount of time. But the next time when you're compiling and uploading this code, it will take comparatively less amount of time. So that's all about the code, and let's go to the challenges and drawbacks of this device. So, like any project, this project also has some drawbacks and challenges. I would like to be honest with this. I was experimenting with ESP32 based displays for the very first time. It was something like a new journey where I was learning and experiencing new things. I've initially tried implementing ESP-IDF to program this board. However, the overall documentation was slightly complicated and I was not able to understand a lot about the ESP-IDF. I tried working with ESP-IDF for around a month, and finding it very difficult, I decided to make a switch to the language that I was comfortable with. That was Arduino IDE. Now, that is a major drawback for ESP32 based boards, as Arduino IDE is able to give you a quick and rapid development phase, but it is not able to implement all different features that the ESP32 hardware supports. Like the board itself supports AI integration, voice commands, IoT based control, etc. All of these are very advanced features which could greatly improve the product's specifications and the usability. However, my ability to work with ESP-IDF was not very good, and I worked with Arduino IDE. I was able to get basic things to work, like the Pomodoro timer logic, the weather update, the water reminders, etc. However, there could have been better updates, including integration of the local temperature sensor. The presence of the IR sensor could be used to control devices within the room. The presence of the radar, which would tell if the person has been stationary for a long time, etc. All these features could have been integrated by using ESP-IDF. However, there is one major positive thing to consider. This whole project is open source. All the design files and code have been shared online on the GitHub repository. So I would like all the users and viewers to go to the GitHub page and take a look at the project. If in any way they can contribute something to the project, it would be a great opportunity for them and for the project to develop. So with that said, I would like to conclude this project by saying that Desk32 is a complete project with all basic functionalities integrated inside this project. It also comes with a battery that allows it to be used in remote environments like a library or a beach or anywhere you would like to work and continue working without internet access. The battery has a backup of 8 to 10 hours depending on the brightness levels. All of these features enable the Desk32 to become an ultimate productivity device. Thank you for watching the video. I hope that you liked the project and subscribe to my channel.